Okay, so we've calculated our standard deviation, sample standard deviation of our x values, and our sample standard deviation of our y values here. The next thing we're going to do is put this towards a formula which will really help us to compile this into our r value, which is the sxy, the covariance of x and y, over sx times sy. And of course we've already got sx and sy, we just need sxy now. So you'll also need to recall that sxy is equal to the x minus x bar times y minus y bar all over n minus 1 values. And there's a summing symbol there. So I'm going to add some columns onto my table. It's really the easiest way to do things, to build up an understanding of my x minus x bar, y minus y bar, and n minus 1. Keeping in mind, of course, that we know that the x bar value, which we calculated earlier as the sum of these divided by 5, was equal to 4.2, and the y bar value was the sum of these divided by 5, which was 17, 26, 36, so that's y bar was equal to 7.2. So now we're going to calculate our additional columns here. So first, x minus x bar. So our columns here go 2 minus x bar, 3 minus x bar, 4 minus, 7 minus x bar, etc, etc. So 2 minus x bar is negative 2.2, 3 minus x bar is negative 1.2, 7 minus that is 2.8, 8 minus that is 3.8, 1 minus that is negative 3.2, and then we have our y minus y bar. And so we get 4 minus 7.2 is negative 3.2, 5 minus that is negative 2.2, 10 minus that is 2.8, 14 minus that is 6.8, and 3 minus that is negative 4.2. And of course we can do this in our calculator as well. But we also need to determine what these are multiplied by each other. So we'll have a final column which will be our x minus x bar multiplied by our y minus y bar, and I'll just quickly do that now. Okay, so I've just quickly determined my x minus x bar times my y minus y bar, and then I can determine the sum of these values, which when I sum these together I get 56.8, and so this is my sxy value almost, but the sxy has to be divided by n minus 1, which in this case is 5 minus 1 because there are 5 data points. So 5 minus 1, I divide that by 4, and it gives me 14.2. And so now taking this value over here, my r value, my correlation coefficient, is sxy over sx minus sy. So my sxy is 14.2 from here. I get my 14.2, I divide it by sx times sy, which is 3.114 times 4.658. Of course we'll put that one in our calculator. 14.2 divided by 3.114 times 4.658, and that is equal to 0.979. Now, we drew the graph of the data earlier. We knew the graph was good. We knew the graph was good. We knew the data was good. We expected a good R value. So just keep that in mind. If you make a mistake, there's a good chance that this will go over 1. If this goes over 1 or below negative 1, you've got a problem. You know you've made a mistake. So you just got to be careful, understand what you expect to get, understand what you expect to get from the data. I can see that 2 and 4 is double, 3 to 5 is almost double, 7 to 10 is a bit less than double, but I can see there's a relationship between that data. I'm expecting a good R value, and here I've got one. So I've got no problems there. Thanks very much. All the best.